Good morning. So you've already looked at, hopefully, the review of the immune response exploration that Ms. Schultz put together. I appreciate that. These are the lymphatic system slides, which we are covering today. We've talked about a lot of immune stuff. We haven't really talked about the main system that's responsible for the immune response, which is the lymphatic system. It's interesting, though. The immune response is not just the lymphatic system. It has a big role in it, but there are other systems that have large roles as well. So you may see that in the reading that you do later on. So hope you had a good weekend. I did. It was great. And let's get started. Okay, so for today, all you really need to do is you've already looked at the immune response exploration, hopefully, and then watch this lecture on the lymphatic system, and then that's it for today. We are getting to the point where you'll start to see things like case studies and things like that coming your way. So when we talk about the lymphatic system, I can't really find a good place for my face. You know what I'm saying? Let's put me way down in the corner. No, that's not going to work. Oh, well. It's cool. It doesn't matter. I'll read the words. So the lymphatic system, way back in the very beginning of the year, someone had this and had to make a poster of it, and it was kind of boring. It was, I think most people used like green to show the vessels, and there were some nodules, and there's only a few different organs, and so it seems like there's not much to it, and that it can't really be all that important, but it really does play a major role in immunity and maintaining homeostasis. Depending on what book you read, they'll list a different number of functions. Our book says 3. The book this presentation came from says 4, but basically it's got some main functions. Number 1, it absorbs excess liquid. When we'll talk more about this specifically, but as your blood circulates, some fluid leaks out. And so the lymphatic system takes that fluid and puts it back into the cardiovascular system. Your blood vessels around your intestines don't do a great job of absorbing fat from your intestines. And so the lymphatic system absorbs fats for the bloodstream and then brings them to the bloodstream so that you can take in those fats from the food that you eat. Production, maintenance, and distribution of, and this is an important word, so I'm going to move my face, lymphocytes. All right, lymphocytes. If I make my head smaller, look at that. Lymphocytes, you guys learned all about last week. Okay, those are those cells from the lymphatic system, B cells, T cells, all of those that help with immunity. And along with that, then the lymphatic system helps defend the body against pathogens. This diagram is super small, but these are the main structures. You can see there's various nodes, the spleen, the thymus gland, which is hard to see. It's this kind of yellowish orangish shape here. They do show a little bit of the small intestine. Your intestines are a huge part of your immune system. But they're not part of the lymphatic system. Obviously, they're part of the digestive system. You have lymphatic vessels. They show one bone, which I think is hilarious. This is the femur, and they show that the red bone marrow is located in the ends of the femurs. Okay, so the ends of your long bones and various other places we'll talk about specifically here in a little bit. It doesn't look impressive, okay, but it's found everywhere around your body, and it helps to defend you against all kinds of bad things. Okay, so if we're talking about, in the unit that we're in, we're talking about why are you still alive? Why haven't you died of COVID? Why haven't I died of COVID? I'm older than you and I have asthma. I could die. I probably won't. But we'll get to that. The biggest function that you have, that the lymphatic system has, is to support the cardiovascular system. And the way it supports the cardiovascular system is as your blood pumps through your body, it's under pressure. Your heart contracts, forces blood out into the aorta, and that spreads throughout the body through arteries, arterioles, and capillaries. Capillaries are very thin. They're only one cell layer thick. And so the pressure of the heart beating pushes some of the fluid out into the tissues. Okay, it leaves your cardiovascular system and goes out and bathes the tissues with nutrients and oxygen. All right, that fluid needs to get back into the cardiovascular system because basically you would sort of internally bleed to death. Your blood volume would drop, your blood pressure would drop, and go into what's called hemodynamic shock. So what your lymphatic system does is it reabsorbs. There are capillaries. You can see them in green up here. All right, they're the lymphatic capillaries. These would be the cardiovascular capillaries. And as that fluid leaks out, It crosses the barrier of going into the lymphatic system and then returns that, as you can see in the next slide, back to your cardiovascular system. Okay, those capillaries coalesce into vessels, lymphatic vessels. The lymphatic vessels turn into ducts, which are larger. Okay, you can see here's some vessels up here, here's some ducts, and those ducts empty back into the cardiovascular system in a couple of different places. There's a place called the right subclavian vein, which is located under your clavicle, and then that dumps back into the cardiovascular system, so you get that fluid return. Okay, we haven't talked a lot about blood vessels. However, cardiovascular system blood vessels have a lining of smooth muscle that can contract, and it can expand based on temperature, hormones, things like that. Lymphatic vessels are not made up of muscle, so they don't have any ability to contract or dilate. And so in order for lymphatic fluid, lymph, to get back to your cardiovascular system, the lymphatic system relies on the contractions of skeletal muscles. Okay, so movement, postural changes, things like that, all squeeze these and force the fluid back towards the cardiovascular system. And there's valves. You can see how it's shaped like this. The fluid flow goes up like this, and then if there's no contraction, it sits back down, won't backflow. We don't want it to backflow. And then next time the muscle contracts, it'll move up. Okay, so that basically that rhythmic muscle contraction will move fluid back to your cardiovascular system. And then if we talk about the organs, all right, I'm kind of in the way here, but the organs that we're going to talk specifically about, we'll get to in a sec, but we can divide them into two different categories. There's those that are primary lymphatic organs, and there's those that are secondary. So red bone marrow and the thymus gland, and the reason they're called primary is because those are where the lymphocytes are produced. Okay, so the thymus and the red bone marrow are where lymphocytes are produced. And then the secondary organs are things like the lymph nodes and the spleen. And those are where lymphocytes are activated and cloned. Okay, so they're produced in the thymus and the red bone marrow, and then they get activated and cloned in the lymph nodes and the spleen, and that's where they're doing their defending of you against pathogens. Yeah, the red bone marrow specifically, in children, it's found like all over the place in the medullary cavity of your bones. And as you age, that proportion of red bone marrow goes down, and it's found in the places you can see there. It's found in the sternum, the vertebrae, the ribs, the pelvic girdle, and the upper humerus and femur. Upper meaning the proximal, closer to the point of attachment. You can see the areas in red on the diagram. People who have certain diseases, leukemias and things like that, where they have defective white blood cells, sometimes need to get a red bone marrow transplant. I'm actually on the bone marrow donor registry. Excuse me. I've never had to donate. But if there is a donation, usually what they do is they will take a large gauge needle and they will try to aspirate, meaning suck out some of the bone marrow from your femur. And it's sort of an invasive procedure and rather painful. However, if you can save somebody's life by donating your bone marrow, I'd say that's worth it. Okay, so bone marrow makes all kinds of blood cells, red blood cells, white blood cells, but it's also involved in the lymphatic system. Okay, it produces lymphocytes. And you've learned all about lymphocytes already, so this is a quick one. Okay, B cell lymphocytes are related to immunity with antibodies. T cell lymphocytes are all about cell mediated immunity. It's early, using macrophages and other cells. So you've seen this, you know the immune response already. The thymus gland, this is one of the other primary organs. It's located in the chest right above the heart and posterior to the sternum. So if you put your hand on your chest like we did way back, oh my gosh, it's been months, your right hand on your chest, that's kind of where your heart is located, just above where you're, just above here, okay, right where your knuckle is, where your thymus gland would be located. It produces some hormones and T lymphocytes. Okay, here's the cool thing. All right, I'm going to just move my head. The cool thing about the lymphocytes is that your body has an editing program, basically. What happens is the lymphocytes are made, and a lot of them, especially ones made in the marrow, they never actually become functional lymphocytes. And the reason for that is that your body has to check them. Right? There's an editing process where they test them to see if they are going to react to normal cells. Okay, your body's normal cells. We talked about antigens and the antibody antigen response. What you don't want is a T lymphocyte to be produced and then be sent out into the systemic circulation and have it attack your normal body cells. Okay, so what your body does is it looks at these, it tests them to see if they will respond to normal cells, and if it does, then they get destroyed. If they don't, and they only respond to, or they don't have any reaction to your own cells, okay, then they get released and they can go do their job. It's kind of an interesting thing that your body does. Okay, lymph nodes. These are actually, a lymph node is kind of an interesting thing. It's a whole bunch of lymphoid tissue surrounded by a fibrous capsule. And they have a variety of jobs, but they filter lymph fluid, removing things like waste products, pathogens, things like that. There are macrophages. Macro means big, phage means eaters. So these are big eaters, and they will eat other particles. They'll eat pathogens. And there's lymphocytes there, which will also fight infections, and they also fight cancer cells. I'm sure that at some point you were sick and you went to the doctor and there was palpation happening. Palpation just means touching or feeling, and the doctor might have reached under your neck like this doctor here is doing and felt for swollen lymph nodes. All right. When you have swollen lymph nodes, that's a sign of infection. It can also be a sign of cancer. It can be a sign of other types of inflammation, but it's one of those signs. It's really easy to diagnose because the lymph nodes mainly aren't supposed to be super noticeable. When you have infection, sometimes they get rather large. If anybody's ever had mono, your lymph nodes can get enormous if you have mono. They're named for where they're located. Okay, so axillary lymph nodes would be in the armpit because the axilla is the armpit. Inguinal lymph nodes would be in the groin because that's the inguinal area. But basically, there's clusters of them. If you look at the diagram in the book, you probably don't even know if you have a book. If you find a diagram of the lymphatic system online, you'll see that they're clustered. Okay, you have them in your axilla, which actually spread down your arm. You've got them in your groin. You've got them in a variety of other places as well. Other areas, okay, tonsils, that's kind of a gross picture, but basically your tonsils are on either side of your throat, and they are intended to be there as a line of defense against pathogens. Sometimes they work really well. Some people, they don't, and so you have them removed. There's a spot in your large intestine called Peyer's patch. This is also a defensive mechanism against pathogens in the digestive system. Okay, your spleen. All right, this is kind of located on your left side, up kind of by the stomach. It's wedged in there. And basically, it's the biggest lymphatic organ, and it's made up of a couple different types of tissue. There's as you can see in the diagram, white pulp and red pulp. There's macrophages here. It's a spot where red blood cells are located and mature. It takes out red blood cells that are worn out. Okay, it's got a lot of functions. You can live without it. Okay, you can live without it. The spleen is not essential because other organs can pick up the slack. However, because it has such a big job with the lymphatic system, which means it also has a big immune response job, oftentimes people without spleens are a little more susceptible to infection and will need, potentially might need constant antibiotic types of treatment because in order to fight off infections, they would need that. That's the last slide. So this is a very basic overview of the lymphatic system. We are going to, probably tomorrow, shift into a mode where we're going to start looking at disease and pathogens specific pathogens. We're going to do a number of case studies, which are interesting, and I think they'll be meaningful for you because you can take all of the information, the structures of the lymphatic system, how it works with immunity, the various types of cellular responses, B cells and T cells, and immune response, and we can kind of put that all together into something you might understand. Okay, that's it for today. I hope you guys have a great Tuesday, and I hope the rest of your teachers are taking it easy on you. Have a great day.